Back to Basics, Episode 1. Let's talk about HTTP fundamentals. So, you've probably written code similar to this multiple times. You write a route or a handler, and your framework turns an incoming web request into a function call, and it just works. Your framework does everything under the hood, but it means there's a whole layer underneath that you've never really had to touch before, and that layer is HTTP. So in this video, we're going to look at it directly, the actual request and response moving back and forth, so you can see exactly what your framework's been doing for you and under the hood the whole time. One quick before we start for this whole series, I'll be using an online store, an e-commerce app as our example or as our sample app. So every example you'll see is something a real store does: browsing a product, placing an order, updating an address. So what is HTTP or Hypertext Transfer Protocol? The simple answer is just this: one machine, your browser, your app sends a request, another machine sends back a response, and that's the entire protocol. So think of it like ordering a restaurant. You tell the kitchen what you want, and a little later, the food comes back. A request goes out, a response comes back. So it happens. It always happens in pairs, and whoever asks waits for the answer. So let's take that request and actually look inside it. This is HTTP. It's just text, plain readable text. The first line tells you the method, what I want to do. For this, we have get request. Next is the path, what I want to do it to. And for this, it means I want to get the product detail with an ID 42 and the version. Underneath that, we have the headers, which are key value pairs carrying a bit of info about the request. And that's the code I showed in the beginning. This is what it turns into. It's just a text message, and your framework has been writing and reading it for you the whole time, so you never had to see it. What can a request actually ask for? That's the method. The verb get reads something, browse a product, or get a product detail, or get user info. Post creates something, place an order, or add a product, or add a user. Put replace something, update your address, update product details, update user info. Delete removes something, cancel an order, delete a product, or delete a user. And patch is like puts smaller sibling for partial updates, for when you only want to change one field. For example, you just need to update your phone number. Put would make you resend your whole profile, but with patch, you send only the part that changed. I'll go into details regarding patch and put in the REST API episode. But two things to remember. Um, get is safe. It doesn't change anything on the server. And get, put, and delete are idempotent, which means even if you send them twice or multiple times, the second one should not change anything. And that's what idempotent means. And I'll get into it more in the future. For now, in this e-commerce example, just know that it's the thing that stops you from double charging your customer or a customer. Here's something you should be aware of. In the past and even today, say, for example, you have a complex search with a lot of filters. For an online store, that's completely normal. That might be a color filter, a brand size, a category, a price range, sorting order, and you send that entire request all at once. And that's a lot to fit into a URL. And while the URL specification sets no official limit, in practice, you want to stay under about 2000 characters, or if you can, even less than that, because browsers, servers, and proxies each enforce their own cap or limit. So instead of using get, we'd reach for post, or we would use post, and it works. But as we've learned, post tells HTTP this change something or this changes something, and a search doesn't change anything. So why not get? Which is the honest choice, because get can carry a body. And there's another reason. Long URL are risky. Your request often passes through other machines on the way, and like proxies and gateways, and a giant URL can trip those up too. So one of those machines might reject the whole request, or worse, your server quietly drops some of your filters and the search comes back wrong with no error to tell you. So in June 2026, HTTP got its first new method since 2010, and it's called query. It's safe and repeatable like get, but it carries a full body request like post. And it's the it's the verb that we always wanted or needed. But the only catch is it's brand new, and servers and frameworks barely supports it yet. So for now, know about it, design for it, but don't ship it. So earlier we looked at what an HTTP request looks like. The answer or response coming back is the same kind of thing. It opens up with a status line, the protocol's verdict on how it went. Then the headers contains information about the data is being sent back. And this time there's a body, the actual data you ask for. And let's say, for example, it's a get request. Same structure as the request, just going the opposite direction or the other direction for the response. And that's pretty much request and response underneath. Both of them are just text, plain text. Every response starts with 3 digits number, and the first digit tells you who to actually blame. 100s are just information or informational. Server is like saying, hold on, I'm still working on it. You will rarely see one. I personally haven't seen one in my career. 200 means it worked, and 300 means somewhere else or a redirect, and 400 are your fault, the client, the one who's requesting. And for example, a 404 means it doesn't exist. A 401, you're not logged in. And last is a 500. And 500s are the store's fault or the server's fault. For example, the server broke and nothing you sent cost it, so it's not your fault. And that difference, your fault versus their fault or the server's fault, matters a lot once we get to the retries. You retry a 500, you never retry a 404 or a 400 error. 401 versus 403, both 400s, and people mix them up constantly. Um, a 401 is about identity. It's saying, the server is saying, I don't know who you are, you're not logged in, or your token expired, go authenticate first. And 403 is about permission. And the server is saying, I know exactly who you are, and you still can't have this information. One best example would be, for example, an admin only page or an admin only information. And there's a bit of a quirk baked into the specification itself. In 401's official name is unauthorized, but it actually means unauthenticated. And it's a permanent misnomer. And half of the internet depends on that exact string. So it will never be fixed. But a recap is that a 401 is identity, 403 is about permission. Next one is 301 versus 302. Both of them are 300 redirects, but the difference can bite you. A 302 is a temporary. The browser follows it, but the next time you request for it, it'll just keep asking it again. But for a 301, it is permanent. The browser writes it down and stop asking. It goes straight to the new address without ever hitting your server again. And that's usually where the trap is. If you send a 301 by mistake and it's cached in every visitor's browser, you can't reach in and delete it. Um, Fixing the server won't change anything. But you're not fully stuck. You can make the wrong address redirect onward, and you should next time keep in mind to put a cache control on your 301s so they can expire or automatically expire when the time comes. But the simplest rule to remember is when you're not sure it's permanent, then use or send 302. Temporary is reversible, permanent isn't. You'll run into hundreds of headers over your career, but there are three that carry most of the weight from my experience, and it's content type. What format is this data? The second one is authorization header. Who's asking? And that one opens up a whole different topic about security, and we can probably have a separate discussion on that in the future. And the third one is the cache control. Can this answer or response be save and reuse instead of asking all over again? And the last one, the cache control, is worth keeping in mind or in the back of your mind, because caching is one of the most powerful performance tools there is, and we usually use that for performance. There's one last thing about HTTP that's really worth understanding, and that it has amnesia. Every request shows up as a stranger, so the store doesn't remember your last one. The protocol itself carries no memory of it, and that's called being stateless. And it's not a flaw. It's by design, or it's a design choice that lets the web scale, and it's what makes a lot of things we built on top of it possible. So the thing you might be asking is, then how does the store remember you're logged in, or what's in your cart? And I'll get into that in the future. For now, just remember that every request starts from zero. So when is HTTP not the right tool? Um, just remember that um, for HTTP, the client always starts the conversation. But what if the store needs to reach you? For example, your order is shipped, or your payment went through. On its own, HTTP can't do that, and it can't just send you a response without someone making a request first. Now back to where we started, and let's walk through it, of what we know so far. So someone clicks buy, and a post request, a plain text, travels to the store, a method, a path, a header, a body. The store processes it and answers back. You get a status line, a header or headers, and a body. 200 means it worked. 400 means it's your fault. Check check your request, and 500 means not your fault. Something happened on the server. Every API you're ever built or going to build is just this conversation happening over and over, and that's HTTP. Um, you were always using it. Now you can actually follow it from start to finish, and that's the end of our episode, HTTP fundamentals, and I'll see you on the next one.